So hey everyone, thank you for coming. Yeah, I've been a bit busy today, so apologies if there's a few last minute issues. Okay, so first of all, we're going to talk through the assertHE package, which we've been developing for our model review. And I want to start by saying thank you to a lot of people who have contributed to this, either in kind of contributing to the manuscript, which is in progress, and I'll share a link to the kind of draft on the progress in this presentation, but also people who've directly tested bugs and things in the package and contributed to the package itself. So the overarching aim, and I guess the overarching aim here in general, and I start a lot of presentations with this slide, is to shift the modeling pipeline from spreadsheet software, MS Excel, to script-based programming languages. So from your survival analysis through your, say, VBA code for a model, to Excel plots, Word outputs, and PowerPoint. We want to shift that whole pipeline through to a system where we are able to perform our stats work, our model, our plots and visuals, our reports, and our apps. So that's kind of like the big picture, kind of where can we get to. So through various publications, a lot with Paul and Well in the past, we've worked with how do you build these shiny apps, how do you automate some of this reporting in Markdown files, and then last year at our HTA, we presented on packaging cost effectiveness models, so a structure by which you can create a package for a model in a set format, and that kind of provides a structure and a template for how to encode models in R. And that looks generally quite similar to what most of the models that I see in R and view in R end up being like. And so often we'll get models where we have a big folder with a load of functions, a folder with a load of tests, etc. And so we'll come to that in a second. So that's kind of the background of the introduction to where we're starting from.
Yeah, and so before Rob talks about the interesting stuff, I wanted to give just a quick perspective on why we're particularly interested in shifting towards R from a pharma perspective. So for any individual asset we work on, we just have a huge range of potential models that might get built throughout the asset's development timeline. But the thing I really want to focus on there is not the breadth of the models, but the breadth of the audiences that we work with, both during the development phase and the output phase of the models. We talk to modelers, clinicians, patients, payers, people with lots of technical knowledge, people with very little technical knowledge. And one of the things we really value in those experiences is being able to communicate the modelling process. So when we build health economic models, the whole idea behind it is that we're building these models to communicate a complicated clinical pathway and the impact a new intervention might have on that pathway. And so it's really important for us that we're able to communicate to the right people at the right time. And this just brings me on to, or the couple of the key considerations for us. So usability and communication, the ability to develop intuitive app-style interfaces using things like R Shiny, and R's focus on data visualization is a huge bonus for us as we communicate these ideas. The other two things, efficiency, adaptability, are slightly more obvious. Obviously, it's great to have an improvement in computation time, and as Rob said, pull everything under one package rather than having to look at Word, Excel, PowerPoint, and kind of pull things in and out of things. And then I guess the last one touches on being future-proof. So we're working with a lot of large language models these days, and being able to include those within health economic models is clearly going to be a future direction for modelling in general. And so I'll hand back over to Rob next. I think he's going to talk through this package of tools, which hopefully will help us not only QC models, but also communicate that QC process, which I think is really important.
Thanks. And thanks in particular to Tom and Yevgeny, who are here, who've been helping internally to test some of what I'm going to talk about on some internal models. So we're testing it not only on some open source models, but some internal models as well, which has been really useful and valuable. So you might imagine somebody says, can you review my model? So it might be that you've got your big our model and they go to an ERG, or it's a MTA and then you go to industry and somebody needs to review that model. And so those of you who have reviewed one of these quite more complicated, complex side of modeling type models will know that you end up with a whole ton of nested functions. It's very, very hard. You've got a load of scripts and it's very, very hard to even start. Like, where do you start with this process? Just understanding where things fit together. Once you get to the code, you're right. It's how do I even start to approach this problem? So quite often you end up with tons of R scripts. Like, what do I do with all this stuff? And this is probably one of the biggest criticisms of R versus Excel, because everybody opens an Excel file, and yes, you've got a lot of tabs, but they're kind of fairly clearly labeled, and you can kind of click through and see how things fit together to some extent, even if I think generally it's harder. So I often feel like this. So, and then after panicking for a while, you kind of start moving through the code, trying to understand the code base. But what would be really handy to have is something that allows you to help review that code and ensure it's working as you intend and as it says in the documentation. So we built the assertHE R package, and the idea of this is to help modelers review and build, because obviously building a model, you should be kind of reviewing the model as you're going along, making sure it's working as you intend, and you might have internal reviewers in your organization. And you might also want to convey the model to other people and explain it, and so having tools that allow you to do that are really useful. So there's two bits of functionality that we really focus on. So first is a whole series of checks. So those of you that have built models in R will know, as you're writing your code, you'll often add in a line that's just a check line after you built something. So you create a transition probability matrix, and you then have a line that says, do all the rows of this sum to 1. You create a trace, do all the rows sum to 1. Is this a numeric? Is this the right type of object? Is it the right dimensions? All these little tests that everybody are writing independently makes no sense whatsoever. What makes much more sense is first to have one package where we just have a function which says check Markov trace, check transition probability matrix. And that's how this kind of project started, was rather than everybody writing their own checks, let's pool our resources. We can all contribute to this package, which then you just install package, check trace, check transition probability matrix, check that run enough PSAs, all of that kind of thing that everybody's kind of doing anyway gets fit onto a package. But then I got really carried away, and then number 2 started, which is how to summarize and visualize the structure of a model. So what this does is it allows you to plot the function network. So any model in R, if it's well constructed, should be a network of functions. So some functions are going to call other functions. Other functions will be kind of standalone, but often you'll have nested functions where you have a whole chain of functions. So function 1 calls function 2, which calls function 3, which calls function 4, and so understanding how all those fit together is really important. So what we've done is built this package which allows you to pass through your project folder for your model, and it will then recognize it will take a folder for the functions and a folder for your tests, and it will loop through all of the code and identify where the functions are, so exactly which line they're specified on, that they're created, and identify where the documentation for that function is, and identify if there's a corresponding test in a test folder. And so as I said, there's 2 different ways to use this. So at the moment it's just on GitHub, not Chrome, as a development version, so you can just do DevTools, install GitHub, and then library assertHE, and then somewhere in your code, so you've got all your model code, and then somewhere in your code you might want to check that your transition probability array complies to a load of rules. And so if you look at the documentation for that function, you'll see all of the things that we're checking there. And so you can say, well, I'm happy with this. This is what lots of other people are using, so these checks are fine with me. And then it just flags if there's any errors. So in this case, there's an error with this array, and so it tells you the transition probability is not valid for these different health states at these different cycles. So this has been done before, and it's just an adaptation on other work. But probably the more interesting bit is what I'm going to talk about for most of the rest of the session, which is to visualize a network of functions. And there's a single function that you can call here called visualize project. And what you have to give that function is a project path. So this is the project directory at the top level. where are the functions? The functions are in here, the R folder. Where are the tests? The tests are in the test that folder. You could have them in somewhere else. You could have a function folder called functions or a test folder called these are my tests, whatever you want to call it. And then you just need to say whether you want to run coverage of functions to see what the code coverage is like on those functions. So there's the different kind of arguments to the function. As I said, there's a lot. So on the first side, there's a lot of these different checks, and they're all kind of included in documentation. Yeah, like they're useful. Everyone's writing them. Don't think this super interesting, but it's something that as a group, I really strongly believe that we should all be pooling together. So if you do want to contribute a check that you're using internally in your organization, and you're just you're using it routinely, then please send me a pull request or send the code, and we can build it in. And so eventually we'll have a whole load of these checks for different types of models. So currently we just have Markov models, but we could have checks for PSM, for BIM, any type of model, all in one place, so that everyone's kind of validated this bit of code. But probably more useful is the model reviewer, so the visualization. So this is what gets spit out in HTML from the reviewer function, and so this is the run SIG model, and the run SIG model has 5 subfunctions. So the function in the middle calls those 5, so the arrow denotes that function exists or is called by the function which the arrow is pointing to. And this is a very simple model. So these 5 functions are called sequentially. So there's a parent and then 5 children. And these 2 functions here are not called by run SIG model. They're used somewhere else in the code base. But what we can see is that very quickly that those 6 functions in the middle all have tests associated with them. So it's gone through and it's recognized these are our functions, these are names, and these ones have tests. So they're denoted in green. The one that's orange is orange because it has a test, but its code coverage is between 20 and 80%, and the one in red doesn't have a test. So we can very quickly see where are our functions, and do they have tests, and how do they fit together. Now obviously that's a very simple model, but we can click on any one of the nodes, so any of our functions, and we see the function name, we see where the function is located in our code base, we see where the test is located, and we see the coverage. So it's kind of a summary of every constituent part of the model. Within this HTML output, we can create new functions. So just for discussion purposes, so say we had a meeting internally, and we run this visualizer, we get this output for our model, and we say, right, we want to build in this new part of the model, or this new algorithm into the model. We can construct our own nodes just in this visualizer as a communication tool to say, now we're going to build this new function that does this new thing, and that gets called by an existing function, and that's our kind of plan going forward. So it's also useful as a kind of planning tool for your modeling work. But what's kind of really interesting from a future-proofing perspective is we can generate a summary of any of these functions. So the I symbol basically takes you. So the I symbol basically takes you, produces a pop-up which displays the function code. This symbol basically takes you to our studio, to that location, the function, as you expect. But this robot symbol basically it generates a large language model summary of the function. So as we talked about already, large language models are not very good if you provide thousands of lines of code and tell it to summarize it or tell it to talk about it. But if you provide it 5 lines of code, suddenly it gets a lot better. So if you have a model that's built up of lots of small algorithms and you send those to be summarized, suddenly you get a much better output and result. So rather than sending your entire model to be summarized, what's going on, we want to understand in layperson summary, what does this one function do? And so then it generates a 2-paragraph summary. So just a short bit of text summarizing what this function does. And the way this works is that when that button's pressed, the function data is extracted. So we take the body of the function, the arguments, and the oxygen code, store that all as data, create that, pass that all together into a prompt, and then send that via an API request at the moment to OpenAI, and receive a response, reformat it, and then show it in the modal. So it looks like this. So from your clicking that button, you then just get this short summary. And so we've run this as a few case studies. So we've done the nice RCC model. So thank you to Dawn and Darren that we heard earlier, first presentation. We've done the Six Sigma Pack teaching model that we published on a couple of times. We've done the CDX2 CEA model, Fernando published back in 2022, which is an R package, and several others that are described there. And then the GSK team have been doing some internally, and several of you have contacted me and said thank you very much for implementing those internally and telling me about all the bugs in this software. It's been really handy, and for those of you who've sent pull requests to help improve it, that's fantastic. So the code for this is completely open source. So here's an example of one. This is the CDX2 biomarker testing output. So you can see there the function network is actually slightly bigger than that, and then a summary of one of the functions that's generated. This is the Sheffield microsimulation model that's built by Dan Pollard. So this is kind of what that looks like, and then you can see a summary here of where the function is, function location, test location, and this is fully interactive. And the same for the nice RCC pathways pilot. So I'll use a couple more minutes.
Should we just leave that slide up?
Yeah, I don't know where I put it. I'm just trying to find the... okay, that's fine. So yeah, if you want, I can send some examples. So it renders HTML output. And so what that means is that you can then share that visualization via email to whoever you want to share it with. So in terms of next steps, we welcome contributions, testing the software on your own models. The software is fully open source, so you can just download it from GitHub and test it on your own models. What we'd request is if you do use it, please let us know how it went. Either say, fine, no problems, or tell us what the issues are so we can help kind of improve this going forward. We're going to expand some of the testing functionality that it does provide, and also integrate. So at the moment, it returns a 2-paragraph summary of each function when you click on there. What we could do is build in sort of almost like a chat bot, so you can ask questions about the function and respond back and forward, which is really cool. And then also we're looking at whether we can fine-tune a large language model, because we have a lot of teaching material, and so we can take that teaching material and the code and then fine-tune the large language model so that it gives a better response than the model just developed by OpenAI, or we'd hope anyway. And then finally a CRAN submission at some point. So if you are interested in having a look and commenting, or you do have any comments, I'm conscious it's late and we want to get to the pub, have a look at the open access publication that's linked here and on GitHub, and just let us know. Feel free to make comments on there.
Cool. Conscious that obviously everybody wants to get to the pub, so probably we'll limit this to 2 questions, so fingers first. Who have we got? Who wants to ask one? Go ahead.
Rob, so obviously I love the package, the unit testing, visualization is great, but my main concern would be giving users a false sense of security, because this is not equivalent to a full verification check. So it wouldn't pick up if the wrong transition probabilities have been put in the wrong place, or the treatments are being permuted, these sorts of things. So there could be still something massively wrong with the model, but this would say 100% pass rate. So I think that caveat needs to be much clearer when we're communicating this tool.
Absolutely, yeah. No, so I mean, if your code is wrong, it's still wrong, right? Like this is for visualizing the model. It won't necessarily find the errors. I guess what I would say is, as an industry, we probably aren't very good at testing our own code, and like people from software development would probably come in and look at health economic models and be like you guys aren't doing a hell of a lot of testing, and so maybe this will nudge people towards at least writing some tests, even if the tests don't pick up everything. At least there's some, and it's a start. So yeah. Cool.
Do we have any questions on the chat?
Oh, sorry, that one. Yeah.
Well, that's brutal from John.
Thanks, John Luca.
Okay, so are there any plans to make your visualization an RStudio add-on?
No, I don't think, to be brutally honest, no. I think that'd be great. If RStudio call me up and want me to come work on it, then great, but no, not currently.